Okay. Yeah. Good morning, everyone. Welcome, Mr. Varianto, and also my colleague, Mrs. Walida and Miss Tonya, and my lovely students, all of our lovely students. Uh, may In this computer engineering session, we will have a lesson about the Internet of Things or IoT. Our lecturer here is Mr. Varianto from XChem Department, XL Asiata, like Mr. Boy that we already know from the first webinar. I understand some of you come from non-IT backgrounds, so this is the opportunity to have a knowledge about the IoT technology that can be useful in actually any area. And also the material in this topic will be very important because you have IoT mock-up project as the final project. So please contact your teammates if they're not joined yet. Okay. Without any furthermore, please welcome Mr. Varianto. The floor or the screen is yours.
Okay, thank you, Ms. Dina. Good morning to all students, to all lecturers from IPB University. Before we go through the session, I would like to introduce myself. My name is Varianto. I'm from Excel Axiata, more particular from IoT Lab department. It is an honor for me to join all of you in this summer course session. As you might know that we, Excel Axiata and IPB University have been long gone with the partnership in developing IoT use cases and all the knowledge sharing between us. So again, please welcome in this session and please enjoy because I don't know, I hope you are not getting bored of this session, yeah. So let me start by sharing my screen. Okay. Can anybody see my slide?
Yes, clearly, Mr. Varianto.
Okay. Thank you, Ms. Dina. Okay. So today, as Ms. Dina said, we are trying to get some sharing about this topic, which is Internet of Things. As introduction, maybe you have heard the webinar that we are trying to optimizing all the verticals or the use cases such as in agriculture, in smart city, in general in industrial revolution, which is known as Industry 4.0 currently. And I'm trying to get it as broad or as general as possible because as said by Ms. Dina, it is you came from various backgrounds, so I'm trying to make it a broader. But if you are having a technical questions or some concern, then please let me know. If I can answer you, then I'll try to answer it directly. But if I'm not able to answer today, I will try to get it something and get back to you. Okay, again, my name is Varianto. I came from the IoT lab from Excel Axiata. For some of you that you still not familiar with Excel Axiata, Excel Axiata is one of the cellular operator in Indonesia. But in this particular technology development, we are trying to join all the stream that comes to the future, which one of them is the IoT. So the management decided to build this lab in year 2018. So we have been around 2-3 years back from now. So in this session, you may anytime ask me if I'm delivering some topics. You could do your chat box or raise hand. I will occasionally check the chat box because sometimes it's quite difficult when you are showing your screen and seeing the chat box. But let me know if you are having questions. And then also I would like to share this event as a discussion, more on discussion. I mean, you can share your thought, your opinion on the subject, and whatever we can discuss based on the subject. Also, sometimes my connection used to be getting wrong. Please also notify me. Should I repeat it again or something is not clear? Okay, but before that, can you guys tell me uh, from which university you are, and then let's say your country, because as Miss Dina also said, there are not only a student from Indonesia, so maybe I would like to know where are you coming from, also your uh, major study. Maybe I would like to see some of you. Maybe you can put it on the chat box. Okay. Wow. Okay, it's coming from Indonesia. Okay, from IPB, from UPM, Agriculture. Wow, okay, Nur Saida. Selamat pagi, Nur Saida. Also, Polytechnic Tengku Umar, Malaysia. Oh, okay, Civil Engineering. Okay, Computer Engineering from IPB, Ridwan. Selamat pagi. Eric Ali from, okay, Malaysia, UPM, Horticulture, okay, Agribusiness Management. Okay, IPB Accounting, okay, selamat pagi. Oh, there's Melenio also from Philippines, okay. Magandang umaga, Melenio, selamat pagi. From MMSU, Agriculture, okay, yeah, okay, thank you everybody, okay. So I see a lot of teams coming from agriculture, from also Rustam, okay, magandang umaga, from Tarlac Agriculture, Animal Science, okay. Okay, thank you everybody. So good morning everybody. Okay, thank you. Yeah, basically I got it now. So a lot of from agribusiness and okay, various background. Okay, thank you very much. Okay. Okay, let's start with okay. The discussion today, I would like to divide it into three parts. The first part is why we should know or should understand the IoT, and then the second topic will be what is built the IoT itself, and then we'll try something to use whatever we have now to make you feel how the IoT is, because also you have a final assignment maybe related to the IoT itself, and then I hope that at the end of the session you will have something related to the IoT. Yeah, so I hope you enjoy this session again. And again, feel free anytime you are not clear about something or about the topic, just directly ask me. Okay. Okay. Before we start, I don't know if you have seen this drawings or this picture, but it is said that if it's not mistaken, it means year 2000. So it is a drawing that very old, I would say that. But can you guess, guys, in what year this drawing is made? Maybe you have some guess. Please let me know. But it is quite very long time ago. Yeah, maybe you can guess. So the picture is showing in year 2000. People will talk using the communication system. They have a speaker on the left, and then the man is holding the microphone, and then on the screen they see the far end guys, the far end ladies talking. Maybe you can have guess in what year this picture was made. Just guess, just guess. No wrong or right. Okay, it's coming. Yusuf said 2000. Okay, 1940, 80, 50. Okay, 55, 30. Okay, okay, thank you. That's a good guess. I think it's a good guess. But you know, the oldest guess was 1920 in here by Raifido. He said it's 1920. Or Rustam also said it's 1920. But you know, guys, this picture was made in this one, if I'm not mistaken, 18 something. This one. So you can imagine all this his picture was. This was drawn by French artist, and he wrote it in a book. Then it's published, and this is his vision. I forgot his name, but it was maybe 130 years ago, if you aware. So at that time, people already having their vision. Yeah, usually most of this thinker was an artist, and then it was implemented by the engineer. Some ideas work like that. So this guy is having a vision that in year 2000 we will have such as this model of communication. And guess what? This is what we have today. So another centuries, the vision is come to the reality. So if you see the left side ladies, is actually on the different location. So the right man and the ladies on the white shirt is on the room, but the left uh, blue shirt lady is on the other room. That's what happened now. So this lady is a hologram on the blue shirt. She was actually Excel Axiata CTO at that time, and the right is Ministry of Communication and director of the Excel Axiata, the white shirt lady. So this is what we have tried during the 5G testing. So you can imagine now that maybe someday you will have a discussion with your lecturer, and you are sitting on the home, but your lecture come in front of you in the form of hologram. So this is actually happen now. Yeah. In some other cases, you might heard the with the 5G, it's coming the new various use cases such as autonomous cars, the cars without drivers, and then also the remote surgery and everything. But the thing is, the technology, something is still on the vision from years back, a long time ago, but now it's more and more getting real. So I would like to say that please do not stop your vision. Please keep innovating. Please keep your mind is open and broadened. Keep follows all whatever happened around you, and hopefully you can catch up with whatever you will try to get in the future. So we are talking now why we need to know, or why we need to understand about the IoT. Yes, because now it's the time. Because if you see from the years earlier, 18th century, it's started with the invention of the steam engines, and then become machinery on the assembly lines of the car manufacturers and everything, production, and then going next with the robotic things without human, while this the early 20 is still so many labor use, and then the next is all done by the robotic hands, even the factories. So people trying to lose their jobs because it's replaced by the robotics, and even now all this robotics and all those autonomous things, now it's connected to the internet. That's why it's the era. It's now you need to follow all these what you call the phenomena. You need to understand it in order you can catch up with the future. Again, it is not IoT only which built the industry revolution. It's came in one pack with the other technology like the AR. You might heard this AR is one of the trend also right now, and also of course the big data and cloud computing, which happen because all the things is sending data. People are having generated so many data in social media also, the objects. That's why a lot of data is going to be very, very big amount of data generated. So that's why we trying to boost the knowledge of the people to understand more and to use this IoT for our, let's say, to make our life better. Yeah. And if we see the trend from the Google trend, yeah, actually as it is said that the IoT term was already introduced actually in early 2000, yeah, but it's become more and more very attractive maybe in early 2010. Yes, we know that there is a Google self-driving cars and then the connected cars and everything until nowadays you might have heard of the refrigerator that can uh, inform you whether you need to buy a milk, whether you need to buy some eggs because it needs to be added on your refrigerator. But I'm not sure today, but you may check in the Google Trend, is it still keep going? But I believe there's still adjustment because of the pandemic and everything. Maybe it's a little bit down the trend, but still keep numbers. The numbers is still growing. So if we talk about IoT, or what is it actually? It's a combination of a few things that able to generate some data through the internet. The thing is actually the device, the physical objects that's having a sensors, and then it is have a controllers, and then it has the actuators. Controllers mean smart things to control the device. Sensors is things that having all the environment condition and then convert it into electrical format and then sending it to the internet, and then it's produce the data so we can use it, and then we can analyze it. The actuator is the way information is sent, then it is converted into some action on the location. Let's say if the temperature is getting hot, and then please turn on the fan. It's something like that, the actuator. Okay, it's not only about being smart or being connected. It's more than that. If you
I'm sorry if Mr. Parianto signal is not uh, hello, Mr. Parianto. Okay, maybe his connection is bad right now, so we have to wait for a while.
okay, I'm sorry, I got disconnected. Let me
Yeah.
try. Okay, so I just tried to repeat. I'm sorry, I got disconnected. I would like to share my screen first. Okay, so can you see the screen, Bu Dina?
Yes, clearly, Mr. Faryan.
Okay, thank you. Okay, again, I repeat from here. Uh, Being able to have the IoT is not only about uh, being smart or connected only, but also you will have some benefit from it, like you will have the uh, monitoring capability. You can see who is coming to your house, what is the temperature of your room, and you can have the automation, like let's say you want to watering all your plants in your gardens every morning or every day. And then the most important thing is you will have some insight of it. So you will have a lot of data. You can use that data, and then you will get some insight from it. So again, for farmers, as example, with a lot of data from the plants, from the cattle, from the environment, what is going to do with that? If we have a lot of data, then it is not possible for us to uh, pro- to process it by human. So this comes some AI capability to process all this data from, let's say, from the drones combined with the satellite imagery to check whether the crops is needed to harvest, or your land is need more water, and your kettles need to have some more healthy food or something. Then it comes IoT, and then the AI as a combination. The technology is going to be used in the future. So again, this is the trend of the numbers of devices. Actually, it has been adjusted, if I'm not mistaken, because in early study, there will be more than 25 device on year 2024, but it's dropping back into 2030. But it's still the prediction is still growing. So okay, so this is the structure of the IoT. We should look at from the bottom one to the top. So usually more easy to remember is we are using the most of time we heard about DNA. D is for devices. So this is more sorry. So uh, some have different view, but nothing is wrong or right. I mean, it's just a few of some definition. As I said, the context is it is the layer that built the IoT. So most of time to get easy is DNA. device, and then connectivity or network. Usually they call it, some call it connectivity, some call it network, and then the application. But some against break down more details, like in the devices itself, there is components. Yeah, like I said, it is consists of sensors and then controllers and then battery, also the power module, and then it's packed up, become call it a device. It's when you think about cars and then locks, and then we call it devices. And then the next layer in the middle is connectivity or network. The function of the connectivity or the network is how to transmit or receive the data from the internet. Some of you may be familiar already with the Wi-Fi, with the cellular technology, 2G, 3G, and then we have 5G now. So this is basically the technology that brings all the data to internet. And then the next one is platform. Platform is mostly these things. This layer is collecting all the data from the device. So later on, by the application of the layer application, it will grab all the data and use it as analytic, use it as information to build the insight for the data triggered below down from the devices or the component. So again, you will see various versions of this layer structure, but to get more simple, some call it DNA, device, a network or connectivity, and then application. That's for the short things. Okay, so maybe some of you haven't seen what is the IoT system by end to end. Let me share with you. This is a, a typical use of IoT architecture. Usually, when you have, this is the example of you have a garden or the plants to monitor. You will usually have soil sensors that monitors the moisture of the soils, and then if you want to have automation on watering the plants, you will have a pump that will trigger based on condition or based on times. It's depend on what's your decision. It has the power component like a battery and the solar panels, and then you will have a small display on it showing the status of your plants, the status of the moisture, and then maybe it's also showing the ambient temperature, and then also put it the display on it. And all these sensors and then actuators is controlled by a small microcontrollers. It is collecting all the data and then converting into the information. And then in this number 2, 3 is actually the network or connectivity that I mentioned before. So the function of number 2 and 3 is bringing up your data from the soil sensor, from the temperature, the data from the your garden to the internet. And this data then produce or keep in some platform that we usually call IoT platform, and then also for analytic and things, we keep it on a certain platform. Usually we put it in the cloud. So everything is on the cloud. So then the number 6 is the interface or apps. It can be the form of the web application or some mobile application that you can monitor your plant's health, and then you can maybe manually turn on the water pump so you can watering your water anytime you want. Okay, this is example. Okay, another example of a common IoT application is like smart metering. Also, it's sometimes uh, being a part of smart city where your electrical usage is monitored by the meter, and then the meter is sending all the data to the electric company. Then it will charge the bill based on the data you have triggered during your usage every month, let's say. Also, there is a water meter, and then the gas, of course. This become more easy with the IoT. So the company doesn't need to send someone to check your billing of your usage of your electrical every month. It's a common use now. And then the below usage is for farming or agriculture. It's also getting many of small farmers, or even the new farmers is using the technology for their gardens, for their farming, so they can monitor it, the plants, the health of the soils, and everything. Another example is that we have is smart city. For example, so many called smart bins that the truck that deliver or getting your garbage is delivered the company truck to take the garbage based on the level of the garbage inside the bin. So when it is already full, then the truck will come to get it. If it is not full yet, then the truck will not come. So it makes more efficient in taking the bins. And also this is uh, it's the fire detector or fire alarm. It is usually connected with the fire brigade. So whenever the fire is raises on some buildings or some houses, it will trigger an alarm to the fire brigade, and the fire brigade will directly knows where the location, and they will take the immediate action to come and fixing all the problems. And also the most common use is the street light, where usually it will on and off based on the sensors only. But nowadays they have monitoring the usage. They can easily manage the lamp or the light which is having problems, and directly replacing it with the location. So they will notify to the authorities where the lamps need to be replaced or need to be fixed. And the other general usage is for smart parking. These things is usually put it under the parking area, and then it will tell you if there is a cars on top of it, or it is still empty. So we see a lot of smart parking application now. So you can book your parking spot prior to comes to the malls or prior come to the buildings in order to make sure that you have a easy parking or to get more closer to the gates and etc. And then also it is many IoT use cases in the consumers for house application. Let's say now you can some devices are able to identify who is in your house. It can detect the face, so I know my sister is coming, my father is coming, is on the at the house at what time. It's detected by the camera and everything. Also, the bikes sharing, it is also quite big implementation of IoT, and also some trackers for your luggage or your baggage. Let's say in the airport, and it will notify where is your luggage, and it is monitored by putting the sensors on it. Basically, it's so many things. Okay, that's the first session. Maybe you can share me what is IoT implementation that you already know, maybe on your city, maybe on your apartment or something, or on your house. That's something like IoT. Maybe you can share with me. Yeah, anything that you thought is, I think it's just IoT, or you are sure this is IoT in your city, in your whatever. What kind of IoT that you know already? Anyone, please use the chat box if you want to share. What is IoT application that you know so far, or you are sure that this must be using IoT that already implemented in your house, in your city? Ah, Honza, okay, street light. Okay, this, yes. Yes, street light sometimes coming in the form of IoT. Sometimes they just using a simple light sensors. It's not IoT, but it's more easy to get a IoT from there. Okay, thank you, Honza. Anyone else want to share? Okay, fill the attendance with fingerprints. Yeah, okay. Okay. Okay, yeah, it could be an IoT also. Yeah, because it has a sensor for the fingerprints, and then the database, maybe it's on the cloud, and then if the fingerprints are exactly as a database, then you can open or you can mark as present to the school or the. Okay, yes, Arduino board is the one of the IoT things. Yes, Sarifa. Yes, we'll talk about Arduino later. Okay, Ridwan said automatic outside umbrella if rain so and so, usually on outside bench of. Oh, okay, that's nice. I just know this thing. Okay, that's cool. You have it's coming rains and then the umbrella will open. Okay, okay, that's nice. Okay, thank you, Ridwan. Suraj Raman said automatic gate. Yes, of course. That's one of the IoT also. like when you go to buildings or you go to the malls, maybe it's IoT enable also automatic gate. It's yes, it's possible. Like if it is you combine it with smart parking application, they will open the gate for you once you are registered as the visitors, the validated visitors. Yes, it could be one of them. Okay. Okay, Rahman said it's smart plugs. It's okay. It's cool also. Yeah, yeah. We have these things. Smart plugs is when you want to mm, turn off or turn on something based on times or based on whatever you control it. Yes, it can be part of IoT as well. Smart refrigerator. Yes, of course. Melanie Lopez said bus tracker. Yes, this is one of the IoT application also for the municipal or the government that want to track the route or want to make the route is efficient. The number of passengers, yes, also yes. Lie detector. I don't know if lie detector from Catherine. House alarm. Okay. Okay, thank you. Yes, basically, yeah, you know that it's, I think you are aware now, that application is using the IoT. Yeah. Okay. Then what next? After all this typical use of the IoT that pretty much various use cases, what we call it the verticals. They call it verticals. And then when it comes to the latest technology, we have a 5G now. It's getting higher speed, much faster speed, higher bandwidth, and then lower latency. Then it comes a lot of new things like VR, AR. Maybe you have heard of it, and you already try somehow these things. It will generate a lot of more use cases in the future, or even start it from now, because the speed is 5G will deliver very fast and very high bandwidth, also very low latency. So I can push the button now, and then directly somewhere it will just triggering something. That's the use case of the 5G. For example, like as I remember, for the cars factory, they start using 5G as their part of assembly lines, which is increasing their productivity and also making it more safe for employees. So yeah, this is a lot of things that will come. Like I mentioned, like autonomous cars. It is possible right now. Maybe some. I don't know. Maybe if you see in your city or something, that means 5G is already come to your city. Okay, this is, I think, the first session, the end of the first session, why we should know, or why we should understand what is the IoT. Then we'll come to more technical. Before that, any question from this previous session? Please, if you have any question, please using a chat box, or you want to raise hand to speak. It's okay. Okay. Ridwan, you have a question? You want to talk or you want to use the chat box, please, Ridwan? Okay, it's okay. Ah, okay. Yeah, yeah. Okay, yeah, Ridwan, it's okay. You can turn on the camera and make it okay, no problem. Okay, if we want to create an idea of IoT, but we still not familiar with the tools or component that's available, how should we approach the process of making the IoT? Okay, okay, that's a good question. Okay, I would say that um, if you know, there are a lot of enthusiasts, I would say, that it's not coming from the technical background. Even they are very broadened areas where it's far away from the technical, but somehow they manage to build something and then to create a product. It's possible, you know. I mean, with this all era of information, it should be easy for you or anyone who wants to build an IoT by yourself. I mean, all the information are available, Ridwan. Your eagerness to learn, your willing to understand things are more easy than ever. I mean, during my time or at school, it was very, very difficult to to get some information to understand something. But you know, with this era of the internet, you can find almost everything on it. You can learn everything from it. If I recall, if I want to learn something, I have to see books in the library or to buy the books to understand something. But now you have a very uh, uh, broad of source of information with you. Then you can manage to use it uh, to to reach or to build your purpose. In this case, is IoT. Uh, that's the first thing. Your willingness to learn the new things, your willingness to explore new things. That's the one of the your first key. Uh, your question is already a good start. You want to know how to build it. Then the second one is nowadays, beside the information, also you have all those um, what you call it, the tools, the devices is already or available on the market. I mean, the marketplace, especially. You can learn to turn off, to turn on the light uh, automatically. Very easy way to start your IoT things. Even you can develop the application itself without knowing the coding. So there are a lot of some platform that it's called, I forgot what it's called, but you don't need to understand programming to build, let's say, Android apps. Maybe you have heard some little girls successfully built an application for renting their house or their apartment. I forgot, but they are very uh, uh, little girl. I would say maybe it's elementary school. Maybe I. That's the thing. I mean, we can learn from the available information, and then you can buy by yourself to try it by yourself. And this This IoT also, if I'm not uh, mistaken, was also similar as the if you heard the makers culture, meaning that you can do it yourself, DIY things. It is pretty much will help you either now or in the future to build a solution or build a product IoT. So the culture is there, the tools is there, and then the information is already available. You can choose the device. You want a cheap one. You want to start with the simplest one. You can have it. You can have it now. That's what I'm my answer right now. But again, this is very good way for you to have this such question, uh, and hopefully by the end of this the session, you can have some imagination how to build something or what do I need for this IoT stuff. I hope that's answering your question, Ridwan. Yeah. Okay. Okay. You're welcome, Ridwan. Okay. Let's go to the other. The next slide. Okay. This will no. It's technical, but I think you should know about these things basically. Like Ridwan asking, where is do I need something? Yes, this is what will you need later on to build the IoT stuff. The first time is the device. The device is consisting of the microcontrollers. It is the brain of the device. It is the thing that will control of the sensors of these actuators. And yeah, if you want to start the IoT stuff, don't forget to bring the first one is the microcontrollers. This is the brain. This will control of everything what happens in your IoT device. Maybe I can divide it into low end, middle end, and the high end. What's the meaning of this? In the low end part, this is the most common development board you will see if you jump into the IoT. We call it Arduino, the platform. Why is it low end? Because it's very limited capability, limited processing capability, and then also very small amount of memories, very limited input output ports on it, and it's pretty much simple for doing simple tasks, repetition things. Let's say you want to turn on, turn off your water pump or something like that based on times and everything. You can use it very easy. You can use it. The most common is Arduino, and then going to the middle end. What is it? What's the difference from the low end? Besides the still limited capability of the chip, the limited memory, the limited input output, but this guy is ESP32 from the Espressif. It has the connectivity for the device. So this one, this left Arduino, still the board doesn't have Wi-Fi, doesn't have Bluetooth and everything, but in this module, this ESP32, it has connectivity or network capability built inside this module. So that's why it's I would categorize it as middle end. So again, this tool is still a microcontroller base because it's a small chip controller and very limited memory, RAM, and then very limited input output. And then the next one, the high end, I would say the high end, it's like a computer actually, but it's in the form of very small form factors. The very famous for IoT developers is from Raspberry. It's Raspberry Pi. The device is like your computer. It has a LAN port. It has a USB for your mouse, for your keyboard, for your USB things. You can still have ports on it. And also it has audio, if I'm not mistaken. It has a separate memories. You can put a memory card on it. It has separate RAM modules on it. I forgot the graphic modules. I think it's separated also. So this thing is called the single board computer. It has a higher computing capability. It has a higher RAM. It has a lot of I/O ports that you can use comfortably with your mouse and everything. So that's why we call it high end. Okay. Okay, what's the difference? The difference is, like I said, this is the microcontroller. Is very small, very limited capability, limited ports, limited memory, while the single board computer, it has a port of LAN port. It has also wireless connection. It has capability to connect to Wi-Fi, for example, also already, and then a lot of I/O, a lot of memory stuff separated. So it's the different basically. So it's later on you will notice that when you want to build an IoT, you need to choose the most appropriate solution for you. If you don't need such as difficult things to handle, you don't need to process an image, you don't need to know the object recognition, you don't need this single board computer. You don't need this SBC capability. Instead, if you are just doing some small things, repetitive things, use the microcontroller base. It will reduce the cost. It will make the solution more easy for you, and then your product will be uh, very compact usually when you use the microcontroller. Also, you will need some knowledge of the things to communicate each other, how the things communicate with other microcontrollers, how the things to communicate with the sensors. It is some protocols that's commonly used between microcontrollers and sensors. Usually, the sensors will state what is the protocol used and how many cables you will need, or what type of connectors you will use. Yeah, you need to understand this in term of connecting the microcontrollers. And then again, for basic codings, when you work with the device, usually you will need to understand some programming language. It will it will control how the device react or the device behavior. If you ever learn about this language, it will very benefit. You know the C, C++, Python, and Java. It is usually most used in the device. And then on the gateways part, you will gateways means network. Yeah, it can becomes a small computer as a gateway. They can reroute all the data from device to the cloud, to the internet using gateways. This is 2019. Yeah, maybe in the future it will change. Maybe some prefer new languages that will come. I don't know. I'm not based on coming from programming background, so maybe some of you is more familiar than me on this part. So this is basically the top IoT programming language that used recent years. Then maybe it might change in some next years. So there's PHP, Python, Java, JavaScript, and everything. Okay, basically this, when you are new that to the programming, it's usually taking you, I hope that very short time to learn this programming language, because a lot of examples, maybe you can took it from GitHubs and everything, because normally it's already in high level language. You don't need to understand the machine language or assembly language, because it's very difficult. I learned once, it's machine or assembly, it's very difficult. You like put this data on register R4 and then move this data to this memory, something like it. It's very difficult. Nowadays, it's very easy to learn this. I took C. Maybe you can easily, because it's human human readable or human understandable. It should be very easy for you to learn C. Let's say C is most common use for the Arduino, and then ESP. When you comes to the Raspberry Pi, maybe you can learn about this Python a little bit to be able to use, let's say, what is it, image recognition, like a TensorFlow and everything. It's higher and more complex programming language. I think everybody could learn from the what you call it, the template or something. You can modify it, and then you should be able to learn from it. Okay, and then this you also need some kind of tools. This would be a tools when you are dealing with programming. It's call it IDE. It's a tools for you to program, to debug, to know the structure of the your programming. It's a lot of IDE. Arduino, it has its own IDE. Also, you want to build an Android apps, you can use Android Studio. Also, you can use Visual Studio, Platform IO, and everything. Basically, just tools. Tools when you want to code or you want to program your IoT device. Okay, let's go to sensors. Okay, this is one of the common in IoT because IoT is things meaning that it's not capable of sending information yet until you put it a sensor. Sensors is like a what you call it's more like a transducer. It's they modify all the heat the temperatures into electrical signals. That's the function of the sensors. Let's say you have you want to check the ambient temperatures or the heat of something, and then the closeness of something. Yeah, there is a lot of sensors you can choose. Yeah, like GPS. You want if you want to know the location. Again, in building this IoT, you need to know also the specification of each sensors. Let's say the resolution or the precision of the device, how long it can detect to measure the distance, let's say, and then until how many degrees of cold of heat that you want to check for the devices. You need to know it because it will reflect on your IoT solution. For example, if I want to check the water temperature, then you will need to think how long it will be on the water. Is it just sometimes you put it on the water, or you want to put it 24 hours in whole years? Then you will need a better sensors. Then it will come what we call usually industrial grade sensors that usually comes in the more expensive than the common or maker's solution. That's what you need to consider. If you want to doing a prototype, if you want to doing this what you call MVP products or the minimum product for the customer for the beginning, yeah, you can use the cheap, the readily available sensors. You can find it in marketplace. It's very common now. You can use and you can pick up from the ready solution. Okay. And now we are talking about the actuators. Actuators is something that the other ways of sensors. It's doing things for you. Like I said, if let's say I want to leave my house for 3 days, and I want to automatically to turn off my lights on the garage, and then I need to set it relays to turn on the light every 6 p.m. and turn it off on the 6 a.m. Then I can use this relay to turn off. Also, sometimes it comes to we need to the motors, like I want to open and close the curtain automatically on every morning, every night. Then you will need the motors to solve the problem. Yeah, and so many things. It can be in the form of hydraulic or pneumatic. It's depend on the needs. Basically, it's various actuators is also ready on the market. Okay. Okay. In order to be more specific to the sensors, you will need to understand: is it the sensors is analog or digital? Basically, to say the digital is computer is digital. They don't understand the analog signal. But in IoT, there are some sensors that still in the form of analog. Analog means when it comes to the device, it will comes into the form of voltage. Let's say what's the most common is temperature. Temperature usually comes in analog forms and then translated by the sensors into various amount of voltage. It's called the analog sensors. Then you will need the analog port to connect to the microcontrollers. So then you put some codings, and then it will understand that the signal is analog. But in the digital, there's only two forms. It is only 0 and 1. That's why we call it digital. The higher voltage is 1, and then the 0 is the lower voltage. So you need to know when you choose the sensors, you will need to understand what is the input for the microcontrollers. Okay, like this. If coming from this end, if it is convert from analog to digital, it will use the so-called analog to digital converters. So it will change from the analog voltage into the bytes 0, 0, 1, something like this. So this is this should understandable with by the computers or by the system. And then also the other way around is digital to analog, DAC. This one is ADC. If you heard of ADC or DAC, this is basically converting the signals from analog to digital and digital to analog. This is the most important things from IoT, because IoT is sensing. It's sensing. It's translating the environment into the signals that are readable for a controller to process it. Okay, the digital itself is basically still the voltage, but it only has two states. Two state mean 0, which is 0 to 0.8. Its categories is 0, and then 1 is 5 volt, usually 5 or 3.3 volt. That's the representing of the digital. So just 0 and 1. That's it. It's all the form of digital. Okay. Any question so far? Okay. If no question, let's continue with the other parts. This is we will talk about the network or connectivity. Okay. This is the middle part of the IoT, yeah? IoT layer, I mean. So when we choose to build the IoT, or you will have the IoT with you, usually it will comes when you are trying to get the connection to the internet. This is the connectivity part or the network part, we call it so. Again, as I mentioned before, the IoT solution, it can be in various form. Let's say the left one is called it a massive IoT, with the characteristic like a high density but small data volumes, but also required a long battery life, low device cost, because it will deploy on so many things. Like this one is, for example, smart meters, electrical meters, or the street light, or the bin, or what is it? Is I don't know. It's tractors or monitoring the electricity. It is required small amount of data to transmit. So in this left side, we don't need a high bandwidth or the speed to send the data. Instead, we can use the pretty much very limited capability connectivity, like a narrowband IoT, like a low power wide area solution. So again, this is massive IoT, and then the right one, it is the we call it mission critical. Like I mentioned before, for example, this one is remote surgery. Let's say I'm on one. Let's say the patient is on one city. The patient is on the one city, and then the doctors, because of he is a very expert, maybe he is somewhere in other places. They can do remote surgery. That's why we need what we call the low latency, the high bandwidth, the speed, because you cannot be wrong with this surgery things. You cannot wrong to cut something on the patient. That's why we need the mission criticals. I don't know when it is going to be implemented, but the idea was to having such as when you push the button in right now, and then things are react at the same time. At least very very quick decision to make. So this will need high connectivity for this type of critical mission critical, like autonomous cars also. Why? Because when it detects the pedestrian or someone crossing the street, the cars need to directly stop. They cannot go through because it will make an accident if you are not quick enough to do those things. That's why we need some solution like LTM and also 5G nowadays. Yeah, that's why the connectivity is different for the each solution. The some factors you will need to consider is, yeah, because the connectivity, it has different coverage area, it has different data rate, and then also matters security, the scalability, and then if you want to build a solution that should reach another countries, how you will manage all those things, you must think about the global readiness for the solution. Okay, so the summary, there are no single connectivity that suits to all IoT use case. You must select. You must select. Don't get higher or high bandwidth for IoT that it's only needs small amount of data, or vice versa. Okay, this is the common terms when we talk about the connectivity. When you have a wire, it's okay. Then you can use wires, and then if you want it to get things are more closer than you can use a wireless personal area network, or a bit higher. I mean, farther reach. You can use wireless LAN within rooms, inside buildings. You can use it. And then if you want to reach like more to cities, to urban solution, then you will need a cellular network. You need another solution for wide area network. Yeah, you will need this connectivities. It's different based on whatever solution you want to build. Okay, this is the comparison with the short range. You will have a very good data rate, but it's very cheap compared to the cellular that a high quality of service, but you will need more power on it because it's always connect to the network, and maybe some network is already not used, like 2G. Maybe it's going to be replaced, or 3G maybe. In some areas there will be no more 2G or 3G. You will need to understand it. And then also this called LPWA, which is a low power wide area. This is the common use for the IoT, because sometimes IoT don't need a higher volume of data or higher bandwidth, or you don't need to release things. You don't need to really speed on this solution. So you will have this technology. And then, okay, this is the description of this low power wide area, because it is commonly used in the IoT. It can reach about 10 kilometers away. Compared to the cellular, it has the consumption lower. That's why it's quite popular on the IoT solution. Okay, this is just most common use LPWA technology. There are Sigfox, LoRa, and NB-IoT with its own technical things in here. Yeah, you can choose whatever you want based on the needs for the connectivity. Okay, any question so far from the connectivity on the device before we go to the platform? Okay, let me continue if there are no questions. Okay, this is the next part, the next layer. If you remember, we are on the, we already discussed about device, we already discussed the network, and then our connectivity. Now we try to discuss about the platform. Okay, when we talk about this platform, then we will need to understand some of protocols that used from the device, from the connectivity, and then what is the next layer. We will discuss it later. What is the common or widely used in IoT? Yeah. Okay, this is, I would like to simplify on this. Let's say you have a device already, you want to use Arduino, you have a light sensor, you have a fan to cooling your stuff, your rooms and everything. You have the connectivity, you have choose this solution to connect the internet, and once you able to construct the device, the connectivity, then it comes to how on you put the data. The IoT platform, actually, it has it comes in so many forms. Sometimes they already combine with the applications, such as to build the Android apps. They can analyze also the data. But if the platform is only doing things like managing your device, authenticating your users, and then defining operation, giving dashboard or API, it's usually we call it just IoT platform. You might heard some of them blinks, UV dots, and things. Usually uh, they collecting all this data from the IoT sensors. On Excel Axiata, we have a platform. It's called it a Flex IoT. It is made by the Axiata groups for IoT developers. So later on, we will try things using this one. But also you can check out some other IoT platform that's quite famous in the internet, like Blinks or Tinger and so on. Okay. Again, these things you may familiar with it already. This is the everyday that we use when we are using the web browsers. It is the HTTP. It is also used in IoT where you send information to server, and this is the method. You can update, you can post, you can delete things. Yeah, it is also a common HTTP, but it's you will notice that when you are using these HTTP protocols, you will generate a lot of data. You will need a lot of bandwidth to cope with all your data. That's one thing to note. Yeah, you will have a header, you will have a lot of data for this protocol. Okay, another one, what also famous in the IoT application is QTT. It is a very effective way to send the data or receive the data, because it has a capability to only limiting the data needs that to be transmitted. So it is more efficient than HTTP. Maybe to describe this, like when you are joining a group, or maybe email a group or WhatsApp group or something, then when somebody publishing something, if you subscribe to this thing, you will notice that someone is publishing something, then you will heard of it if you subscribe on this broker. We call it broker. It's an entity that controlling all the data transaction. Okay, another protocol used for IoT is constraint application protocol. It is for I would say very effective communication when you have a limited connectivity, like low signal area that's usually in the maybe farming area. Maybe you can enable these protocols. This is basically a simplified form of the HTTP, because it doesn't need acknowledge. If you see this is using TCP, but this one is using UDP. This means that if you are using HTTP, you need to make sure that data already received by the receiver. But in this co-app protocol, it doesn't care whether the data is received or not. So when it lost, then it lost. They will send it on the next sequence. So that's the difference. Okay, again, this is this example of protocols. There are another protocols that used by the IoT, but basically you need to know which protocols you are using for sending the data like this. This is basically sending information from device end into the IoT platform. Also, you need to understand the connectivity modules. Do they support these protocols or not? You need to verify by yourself. Yeah. Okay. Okay. This is the example of the dashboard that I've mentioned before. This is the Flex IoT. This is Excel IoT platform. If the data already collected, then you will have some kind of pretty much simple dashboard to show or to represent what is happening now in the device. Like this one, for example, this one is from the hydroponic solution. You are monitoring the pH level, the nutrition, the water level, the temperature, humidity. So basically it's collected the data and then you can display it on the a form of dashboard like this. Okay, it can be also used for controlling. You can put a turn on widget on it. You can use it also, but it's basically simple dashboard. Yeah. After collected data is received by the SIT platform, you can manage it. You can see it by using this dashboard. Okay, this one is the last one for our theory. This is the application. Application means the upper layer, more layer than IoT platform. Let's say you are having these things connected to the internet using MQTT, and then grabbing all the data in the IT platform. It comes to the picture now, the application layer. This is the highest layer where you mostly capable connecting all this to entity using the API, application program interface. Usually this will more like analytic visualization, and then managing your device also sometimes. Like I said, sometimes they bundled into one single entity, platform, and this application. So you can manage your authentication and everything in the cloud. Okay, this is the example. Like I mentioned, for example, this one is the dashboard on the laptop. On the device, the controller. This one is controller for the hydroponic solution, for example. You will have some microcontrollers or SBC, single board computer on it, the small one, maybe Raspberry Pi or something. And then you can display the status, the data from the sensor here. You can also adjusting something from here. You can set manual. You can check the water level. You can check the pressure, humidity, and things. This can be categorized as application because, yeah, when it's not a part of the because it comes from the external data, they connect to internet, and then grabbing all data from the either from the dashboard or sorry, from the platform, or they can directly showing it from the sensors itself. And you can also give a comment to the cloud, the platform, to do things or setting something. Okay, this is the device. It can be in the application, Android application, or maybe this one is coming from the web. Let's say I have smart home application. I can build an application on my device, like if I want to if someone wants to enter the house, I can open the gate for him, or by manually I can put the camera, and when the camera is detecting something, it will show up directly on it. Okay. And again, this one is the next is analytic. You can, or you will be able to analyze based on the data that we have. For example, this one is the data collected by the temperature sensors within 5 years. Then you will see the trend on every year during the date. Let's say this is March 7, 2011, 2015. Then you will notify something. There is a similarity, there is like a pattern, and then on the right side, you will have the analytic, which is resulting the trend. So this is basically what the IoT purpose. You can analyze the data, you can have the insight that on the next days, it looks like the prediction is going, the temperature is going up or going hotter than today. Okay. For commercial things, with a bunch of very, very big data, you will notice that there are already available some solution or some, let's say, packages from the commercial players like Google, like AWS, and then Microsoft. These things, they are doing very, very advanced analytic when you, let's say, for factories, for shopping things, you can analyze the behavior of the shoppers. You can analyze the factories, but of course, it will need a bunch of very, very big storage on the cloud. So these are examples. Many more. It's already there, but this is just for example only. Okay, I think this is the end of my second session. Then, if you have a question so far, we will need to have some 2-3 minutes breaks before continue to this last part of my presentation. Please, anyone, if you want to have a question or ask something, please do so. We will have a 2-3 minutes break. Yeah, Bu Feldina, is it okay?
Yes, it's possible, Mr. Varianto.
Okay, thank you, Bu. While we are waiting for the question also. Okay, let's see you in another 2-3 minutes. Okay.
Okay, for the students, maybe it's opportunity for you to discuss your problem with your study case problem with your teammates, because Mr. Varianto is the expert of IoT.
Okay, on this session, I would like you to try something, meaning that so you can have some experience on as I was later, I would like to say a small part of this small part of the IoT stuff. And okay, just a minute. Okay, if you see my screen, then since we don't have any device, then we'll try this one is the device that sending the MQTT to the platform or the broker, MQTT broker here. Sorry, this one. Then we train some clients, MQTT clients, acting as device replacement. So in this case, we will try. Maybe some of you will volunteer to do so. Let's try something using these clients to send the data from, let's say, from these devices to the IoT platform. So we simulate this thing, and if we have time, we will try this one also, like application sending all the data, all the requests to the platform, and then instruct something on the things. But just if that we have time, but we'll try this one first. Okay, let me go to this side first. So many slides. Okay. If you are using a Chrome browser, maybe you can install these things. Okay, where is the chat box? Sorry. If one of you is having a Google Chrome browser, maybe you can. Okay, I'll just try to share my screen. I'll try to share my. Okay, just a minute. Okay. Okay. Okay, if you already install this application, you can try to connect to the this one I will show you. This one, the host. You can feel the host. Can feel the username. Let me check the password. Okay, when you have done with this is the protocol in QTTCP, then you can save when there is no problem. You will see this green uh, uh, connected. So meaning that you now connect it to the broker, and then you put this thing, topic to sub and publish. This one and this one, you put it. So once you need to subscribe means you try to listen all the information that's sent to the broker. So I just put this subscribe. Okay, it means I've subscribed this topic already. And then after that, uh, on the IoT platform, you need to follow some rules to send the data. Usually, it's we call it what is called the JSON format. JSON, JSON. This is the format that you need to follow in order to be able a device to send the data. For example, this one, we share you this. Where is it? Where is it? Okay, this is the one set in the IT platform, and then you will need to code something in this, for example, your device, something like this. Credentials. There are some components for username, password. You must follow the data from it. Again, this is the example. And then once you get connected, you need to also use this topic. And then this is example where you need to write the JSON format on your device. Sorry. Oh, you can see my screen. Okay. This is the string message you will need to write on your code. And then the variables will come, the data, the temperature is coming from the data, the sensors, T, temperature. And then the string, the humidity, it's coming from the device. Also, you must follow the format that you will need to put the device serial in it. So this is basically the basic coding. So once you uh, follow the JSON format, you will be able to check on the existing uh, dashboard or the platform. What is the data right now? So in this case, I was putting the hello world in hello in temperature, world in this humidity. Let's say let's try if I can change it into some numbers using this JSON format. Okay, let's say my device want to uh, send based on the sensors, let's say 23 degrees, and then the humidity is okay 70%. Or okay, this is 30. Let's say if it is changed or something. Okay, this one you also need to put this topic to publish, meaning that you want to uh, input the data within this directory or these topics. We call it topics in the MQTT. Then you put a publish. Let's see if something coming. Okay. As you can see, this is coming. I subscribe. Sorry. Yes, yes. I forgot the payload. Sorry. Yes, yes. Lutfi, you're correct. Sorry, I forgot to put this one. You can put this one. You can put anything on temperature or humidity. Let's see if changed. I put 30 and 70. Let's see if the platform is coming. I go back to the platform and then let's see if it is coming. Okay, it's 30 and 70 at 11:06. It's just coming. Okay. Anyone wants to try? Please. Just try it. Let's see if coming to. Oh, okay. It's good. Someone is publishing also 30. You can use your name or university or something so I can see the difference. Because when you put the same number, I cannot see only the time, maybe the time which I could see. Yes.
I'm sorry, Mr. Saryanto, which parameter we can vary it in this script?
Oh, yeah. The parameter you can change is 30 or 70, which is this is the content of the value from sensors. This one, the 30 in my example is 30 or 70. This one. You can put another numbers if you want. Humidity, this one. As long as the format is correct, you will. Yes, there's coming another value. Yes, okay. So someone made it to send the data from, let's say, the device to the cloud. You can change the 30 or 70 with your value, whatever. If you check from the platform, it will reflecting the time. Okay, this is 80, 90, that's good. So you made it. You made it to send the data, simulating the data coming from the device to the, where is the diagram? I was trying to look the diagram.
Is there any specific range that you have to follow?
Yes,
Specific range
yes,
for the temperature and humidity?
yes, Miss Dina. Uh, you you may specify on the code uh, how long the characters or the numbers depend on whatever we want to put the numbers on it. But again, the requirement is you need to put on this certain JSON format, we call it. The temperatures 30 in here, 70 humidity is coming from the sensors. It will directly changes from time to time. Okay, Lutfi said where I can see the result. The result, of course, you can see by yourself when you subscribe to the topic, to the, yeah, we call it, let's say the directory or whatever, but in MQTT, you call it a topic in here. If you subscribe your own to listen, whatever, or whoever sending the data, you will see the result directly in this box. See, it's coming more, 30, 70. Or you can see directly on the IoT platform here, Lutfi. See, Lutfi, can you see the screen of the platform? Is it changing to 28 and 60 on the, yes, this is the result actually. You need to refresh sometimes. Okay. Yeah, I hope you got the basic idea how to send the data. Usually, okay, I try to get back to this. Usually, those temperature is from this sensor. Temperature, humidity coming from this device using MQTT up to the Flex or whatever platform here. And then in this case, we are trying to simulate sending data from device to the IoT platform. So, okay, thanks to all that already uh, 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 trying to sending the data. So now you are able to send data from the device to the platform. Even though we are just using these simulation clients, but that's what's going to happen when you develop your sensors, something like that. So I think I hope you be able to get the feelings now, how these sensors sending all the data. Or you have the link, or you want to link. I tried to get it. Yeah? Okay, I tried to get you the link. Okay, this is the the operation. If I want to share with you, I can uh, add you some links, maybe. Just a minute. Okay, I'll just add some buttons for what was my okay. You private uh, matter. I put here. Okay, I just put here. Okay, temperature and I okay, humidity. Oh, where is the okay? I just save it. That's the link, Lutfi. If you wanna try your value, okay. This is anyone still trying? Okay. Oh, sorry. Okay, another 30, 70. Maybe I need to refresh. Yes, it changed 30 to 70. Yeah, this is yeah. This is a dashboard. Basically, you can put it in the graphics as well, line graphics or bar or something. I think it's provided as well in most of the dashboard. Okay. Okay, let's. I think should be enough for you to uh, try these things. Okay, then I would like to my last uh, or topic was this one. The again, you try already the to send the information from device to the IoT platform, and then again, when you build an application, actually we can build or using Android web device or web-based, or you can put here in all devices. Usually this come with the API. API means some also generate communication between platform that is mostly widely used. Even you can request or requesting all data from Twitter on everything. They are providing the API, and for this purpose, we can use the API simulator, a lot of simulator. It is the Postman that I used to use to check the communication. Like I mentioned before, this one is mostly since I think this is quite taking some time, but I will just explain. If you feel already feeling the MQTT client sending data, and then this API simulator, basically you can grab the data from this your apps, from your mobile phone, from your web to the Flex IoT. Basically, the data is already uploaded here, and then your application can request the data from the IoT platform using this API method. So because of the time, I think it's uh, quite taking some time to use this API. Hopefully you can imagine, or you can have the feeling after you try this MQTT client for this. Okay, I think this is so many. Yeah, so I think because of the time, I would end this the session. So in case you still have a question or anything, please, or feedback, please, please let me know. I return it to Ibu Dina. Thank you, Ibu and friends.
Okay, thank you, Mr. Varianto, for the interesting and very useful materials. Now we have more knowledge of IoT technology, things that can communicate through the internet and the people or user can interact through some application, if I'm not mistaken. Okay. Is there any question for our lecturer? It should be a lot related to your final project. Okay. Anyone have proposed a solution for the study case problem? Maybe the group that have already interviewed the farmer. Anyone, you can share your topic or study case. Which group have already interviewed the farmer?
So the use case is farming, ya, Bu Dina, ya?
Yes, Mr. Varianto.
Oh, okay. So that's very interesting. Related to farming, you will have a lot of data, a lot of things to manage. Then it's very useful case for you to learn and build.
Okay. Yeah, it should be very interesting. Okay, group one, have you already interviewed? Group one, group two, until group 10, there's a lot of group. Okay, Ananda Raihansha. Okay, thank you for the participating. Okay, you can unmute yourself.
Yes, ma'am. Thank you. Is my voice audible?
Okay.
Yeah.
Okay. Thank you. Hello, Mr. Varianto. I'm Ananda Rehansyah. Maybe my question is about IoT in general. IoT, we know that IoT is about getting things easier. And IoT is deliver the information or the data from the sensor to the cloud and user application. But we know that in Indonesia, we were not covered the whole area with a good internet connection. Before we starting an IoT project, do we need to check the internet condition in the location? Or we just can choose the possible one, like maybe 2G or 3G or low bandwidth internet to deliver the data based on the data information sizes. Thank you. Maybe you can explain it to us. Thank you, Mr. Varianto.
Okay, thank you, Ananda. Very interesting question, and you got the point. I mean, you already able to imagine how the IoT will get benefit to you, and also the what you call the challenges that you will face. I think it's very interesting. You can imagine that. Yes, it's true. It's correct that especially in Indonesia we have very big islands there that we made as let's say telecom operators may not be able to cover all of the areas because as I aware, then maybe you also aware that mostly the development of the cellular things, the cellular coverage for communication is for human only, Ananda. You may get very high-speed download in the city as well. Maybe you can feel it. Yes, basically it's the main target of the telecom operators. We excels covers more than 90% of Indonesia, but it's mostly in the populated human areas, not the suburban or the very remote areas. That's come the challenge. You're correct. We also having these problems, the same, Ananda. When we are going to develop some solutions, which is in our case right now is agriculture. Yes, you're correct. Some agriculture is not covered by the cellulars or the internet coverage, like using 4G or 3G or something. Yes, maybe there are 2Gs covered the area, but sometimes 2Gs also cannot reach the area because it's very remote. It is very far away from the housing of the farmers. Usually, you have a land that separated from the population. Usually, it's coming like that in some areas in Indonesia where your house is here and maybe your farmland is maybe a few kilometers away. That's probably it's not covered by the cellular or internet access. Yes, very valid your concern, Ananda. And then how we manage this? Okay, there are some solutions. I mean, if you talk about the data rate, if you more detail, more specific on the farming things, I believe that we are talking about it's not a big. I mean, in certain case, yes, you will need to monitor your plants, your health, your plant's health. Then you will need a picture. You need to send a picture. You need to send a image. Then you will need higher bandwidth. Of course, that cannot use the what we call low power wide area, because it usually using a four small chunk of bit data. But if you want to send an image or don't say a video or things like that, it's very difficult. Okay, we've seen some difficulties also when we try to build some emergency tracking for the climbers at the mount at a few years back. Then the possible technology, which is one is quite expensive, is satellite, of course. We built the gateway around the mountain area. Then we connected the gateways to the internet through the satellite. Of course, it will comes to the higher cost when you are developing the solution, but there are also some solution for the connectivity. Like I mentioned, if we are talking the NB-IoT, the cellular base, it will be difficult sometimes, but in the real situation, you can combine. Such as if you want to use the very small data or very small bit of data for the farming things, like a sensor for soil, for the information on the temperature, and then the, let's say, weather sensors. You can combine between the licensed and the unlicensed spectrum. For example, if we talk about unlicensed, you can search like a LoRa or LoRaWAN. It is basically the unlicensed using unlicensed spectrum. It runs on the 400 megahertz band or 800 sometimes, and it is you can deploy it by yourself by putting some gateways, some aggregators on the farm, and then the device will connect to the gateways, and then the gateways you need to extend it, of course, by certain another technology to bring up as far as possible or as close as possible to the, let's say, cellular or internet connection. Maybe you can connect it to Wi-Fi at the house. maybe you can connect it to the cellular, if let's say already available in certain areas. Yes, you can combine few solutions to solve your problems. Also, if I'm not mistaken, in I don't know, US, if I'm not mistaken, the US, the America, they are using some white spaces for communication between farmers and the internet. They are using TV channels. If you are aware, the TV channels is jumping from, let's say, 50 band, and then the other band is on the 60 or 70. Then there is a white space or unused space here. Then they are using this space for the IoT on the countryside, on the rural area. Of course, there is regulation on it. Then they are working on that because they aware that not all areas like US, like Australia, maybe all covered by cellular operators. Then they use some kind of the technology white space, TV station white space. They are using it, but I'm not hearing some kind of that here in Indonesia yet. But back to what I said, maybe you can combine such as some solutions to use some available unlicensed technology and then combine it with the licensed thing to deliver the gateway connection to the internet. Hopefully it's answer your question, Ananda.
Thank you, Mr. Varianto. That's very clear.
Okay, you're welcome.
Okay, thank you, Ananda. Another question, maybe? Okay, Cynthia. There's
Oh, okay. There is question from
in
Cynthia.
chat box. Yeah.
Yeah, in chat box. Yeah, okay. Okay, Cynthia is asking, I want to ask about, sorry, how to apply IoT to network security if you want to run a business. Is it safe or do you have to use an additional security system? Okay, that's very good question. Cynthia Octaviana. Okay. Okay. Yes, you are correct. If either you want to apply a business or for your personal use, of course, you must build the IoT system or your IoT solution as secure as possible. That question is very, very important because, as we know, like the data that I have mentioned before, the device is getting many and many years to come, and it is quite challenging when we talk about security. And nowadays, many people more get aware of the security issues, especially for the IoT related to the maybe what you call cybersecurity, and then another things is when related to personal data, the GDPR things. Yes, it's very important, Cynthia. You should apply the security level for the IoT device. If you ever heard about the case back in, I think 2016 or something, it's very famous. When maybe you can search what's it called, Mirai botnet. That's very dangerous things can happen when the Mirai botnet was trying to make IoT device into the DDoS attackers. It's like a zombie. It is a malware that implemented in your IoT device. So your IoT device able to attack some or one server or some applications by sending the denial of service. You can imagine if you are not protected enough, if you are not securing enough your IoT device, then you you will be hacked. If someone hack my lamp or at my house, that's probably not really. Yeah, maybe it's a problem also for me. But if, let's say, don't say business, if someone hack my vacuum cleaner robot that has a camera on it, they can jump around, they can turn around my what you call it, robot cleaner at my house. Instead of vacuuming the dust, it is scanning all my house, then looking at my room. Then what can you imagine how come my room is showing on the internet? That's very dangerous thing. Yeah? You can imagine it. Someone could hacking those devices very easily if you aware of. So there was if you see some YouTube, there is a talking about security. They hacked this vacuum cleaner robot that has a camera, and they can easily move to your house to see, to check you have a room, you have kids, you have sisters playing. Very dangerous. Even don't talk about business. It's very dangerous. Then how to solve this? Yes, you need to build the security enough, either in the term of physical or in the term of the data. Yeah. For example, a lot of discussion about it now. For example, if your device is not smart enough, then protect it with authentication, multiple authentication. You choose the secure network on it. The connectivity is secured. Make sure it is secured. You might some of you may know the hackers can easily attack the Wi-Fi if you use the clean username name and password. Yeah, a long time ago I used to hack all the things, but I don't know now. So it's getting maybe much advanced the technique. You can steal your username and password for a Wi-Fi system. Very easy. If you are looking at the unlicensed, then very careful with it. And yes, choose the authentication. Don't send a clear text. Don't use as unlicensed as possible, and then use another authentication from your MQTT or data things to sending all the data. Encrypted things, you should use that. And then from the device things, maybe you need to turn off some holes that usually open, like some surface you don't need, like sharing files, surfaces, or telnet, or even SSH. If you don't need, don't open it, because it will be open to your devices. Yes, it is basic things, but also it comes to when you ask about additional security system. Yes, there's so many things available on the commercials that they are building they build, or they have a solution for your IoT securities. Yes, the summary, my answer, yes, yes, of course, you need to build the security system for your IoT, for your personals, for your even for your business. Hopefully that can answer Cynthia Octaviana question. Yeah.
Okay, that's a very shocking news, but will useful for your IoT development maybe.
Yeah, but it's a separate discussion. So security it takes another session maybe.
Okay, this shocking and disturbing.
Yes, yes, Bo. Yeah.
Okay, maybe I will close the Q&A session due to time constraint we have. But before we end this class, I would like to welcoming Dr. Ina Novianti as the head of Computer Engineering Study Program. May Mrs. Ina give us some words? Okay.
Okay, thank you, Miss Faldina.
Okay, please, the time is yours.
Thank you, Miss Faldina. Thank you, Mr. Varianto. Maybe in our first, this is our first bit, of course. Okay, I will say thank you for Mr. Varianto from Excel Axiata for the great and such interesting explanation about IoT technology. And of course, I will say thank you to for our students of computer engineering program and Miss Faldina. Thank you too for your help. And then I think and I hope this event can improve our knowledge, of course, about IoT technology implementation in industrial area, of course. And I'm sorry, I cannot follow the discussions, all discussion. Sorry, Miss Varianto. And I think we get new insight too, but about implementation of IoT in agriculture or smart farming, especially. And I hope our students can improve their knowledge about the agriculture or smart farming or precision farming. And I think I'm so happy, and I will and I hope our students can continue with another discussions with Excel Axiata. And I think that's all. Thank you, Mrs. Faldina, Mr. Varianto, and our great students of computer engineering. Success for all. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam
Waalaikumsalam
warahmatullahi
warahmatullahi
wabarakatuh. Okay, thank you, Mrs. Ina, for the greetings. So now we will have the photo session. Please turn on your camera for all the participants. Okay, my colleagues also, Mrs. Walida, Mr. Derry, or Mrs. Tonya. Okay. Okay, I will start to take screenshots. Put your best smile, best pose. Okay. Okay, are you ready? Okay, 1, 2, 3. There's three pages of screen. Page 1. Okay, page 2. Oh, there's Miss Nur Aziza join with us also from informatics management study program. Okay, that's all. Yeah. Okay, that's all for this session. Thank you, Mr. Varianto. Hope you have a successful career and have a good health for you and your family also. Actually, tomorrow we will meet again for XCAM IoT Lab virtual field trip. Okay, then for all of my colleagues and the summer course students, thank you for your participation. We can take a break and meet again in the second webinar at 1 p.m. Have a good day. Wassalamualaikum warahmatullahi wabarakatuh. Bye.
Thank you, everybody. See you again.
Thank you.